So yes, welcome back for the third round. Machine unlearning, or AI as a subversive medium. Today I would like to do like a kind of a hello world example with you. Would like to write our first own neural network machine learning code. I'm gonna try to give you certain angles on this topic. So first of all, talking about the basics, like what is this code doing, what does learning means, what does training means. We will kind of talk about certain words and parameters that are involved into this. And then hopefully by the end of the class today we can get a glimpse of like how these networks kind of look inside by smaller examples. And maybe it should not be the full 3 hours, but let's see how fast we are. But first of all, last time I asked you to play around with these platforms. Did you have a chance to do something? Did you figure something out? Unfortunately, I figured out that the left one had some API issues, like it took some time to analyze the image. But did you play around with it, or did you try it? Also things like, with which platform did you like to play around with?
Yes, right.
The PIMI, company from Poland, by the way, again. I think, yeah. Yeah. Did you use your own image or like a generated one?
No, I have used professor.
Of random people, I see. So, I mean, I assume, right, it works quite well, right? Like as we showed you last time already, you can upload an image and suddenly find these people's faces on different web pages, right? And did you try to cover it, or like what does it mean to cover the face and until when it's not detected? Did you try something?
No.
Just look up for people. Well, I mean, it could be also a nice tool, right? Like to look for, I think I heard things like that you could also look for, let's say, lost family members or things like this, right? It could be also quite useful tool, no? The left one, I guess when you were able to play around with, right? Basically, this one is again more like an art project, no? It's not a real thing, but it shows you the potentials of these technologies, and basically gives you a glimpse of how it's been used. So, for example, the left one, as you have seen, maybe tries to identify, for example, your how much money you earn, things like this, right? Just based on your image, which is kind of a crazy concept. And also other things like what's your religion, basically where you come from, things like this. Maybe also your political parties you might gonna vote for, things like that, right? Did you try it with your own image, the left one, and was it kind of matching? Somebody of you?
I tried that one with this viral picture of William and Jen before he got caught.
Uh-huh.
I think, or something like that.
Yeah.
And yeah, it's just like a young man wearing red hooded jacket and short scarf. But it's mostly like about the picture.
Yeah.
It doesn't really say anything about the person, I guess. Yeah, how he's dressed, how old the person is, and how the lighting is in the room.
See, yeah. Or like what is the venue or the place where it was taken, right? Some kind of gallery or things like this, no?
Yeah.
Yeah, I think they're using a free API. So basically also, as you have seen, right, it's also saying there, it's like the Google Vision API, which is public available. Actually, you need the API key. I think the web page is offering you this for free. But saying this, basically, this is using like also one of the biggest vision APIs out there. So the results basically come from big player like Google, and obviously can be used everywhere. Did you try this one by any chance? The thing that we discussed last time, like the typo attack on it?
Yeah, I tried the lesson. I wanted to try at home, but I couldn't find the links.
Okay, yeah. Sorry, yeah, the server was down at some point. I think maybe it was in the moment where you tried it. Yeah.
Yeah.
Yeah, it's back up
Maybe
again.
it would be cool if you can upload these in the base.
It is. I mean, I uploaded the presentation, the PDF.
But where is it?
There's like a next cloud thing, and I think inside there's a folder which I uploaded, and there I always upload the presentations afterwards.
Because you find the folder in my,
I can look it up like after today.
I was not yet accepted to the course.
Oh, really? Ghost students. Damn it. Yeah, maybe to give you another example here. So I uploaded my image and basically I didn't ask, I just uploaded it, and it estimates the thing by itself. Probably there is a system prompt that asks for, please identify, again, political parties this person is voting for, the earning, again, religious, some kind of social stuff and things like this. So here I underlined a couple of things that the system identified. So here it says, for example, that this person owns 30 to 50,000 euro a month, probably a Green Party voter. Also, I found this interesting, like this person seems to have low self-esteem. It's introvert, dishonest, emotional, unstable, not adventurous, and low self-control. Thank you for this. And I was not happy about this, let's say like this, so I tried to attack it, basically to get another output out of it, and then I did basically, as we just said, a typo attack. So I upload the same image, but I told the network to flip certain characteristics in the image. For example, here I said like, no, wait, this is like a healthy man earning 150,000, and basically I tried to do exactly the opposite what the previous example showed me, right? And then I got this one back, and suddenly I flipped the whole estimation of the network, basically. So that's maybe an example, right? Like that we can understand here that these images, or like this network, they not just read the image, they also read certain contexts, and when you give them certain instructions or prompts, so to say, inside the image may be hidden. I mean, here it's quite obvious, right? Everybody kind of sees that, but of course it could be also written on a t-shirt, it could be somewhere written in the background without knowing to the human eye, but the machine is still capable of reading it, no? And put that into the context, so to say. And then suddenly you can, for example, here then I can increase my my earnings, yearly income. I can also increase like the, I think religion I also reworded, and of course also like extroversion, honest, emotional stability, so basically exactly the opposite that was predicted before. I did also another test with this guy, so that's quite hard because a lot of people, or like a lot of systems, they know who's Elon Musk, and it's, takes a bit like a certain fine adjustments, and here it's kind of obvious, right? Like the system predicts somehow, that, how is it called? The income range is like 20 billion to 30 billion US dollars. Heterosexual, what do we have? Yeah, all that stuff. And it took quite a couple of attempts. So I took this one. I mean, imagine maybe this could be also in a newspaper, like, written underneath or something. And then basically we reduced the amount of money Elon earns per year to $30,000. That's what the model predicted. Again, here we had a bit like to tackle or to challenge the system, because again, Elon Musk is always quite known face to the networks, so not all the typos work out straight out of. Somebody else wants to share something about this one or the other one? Do you have something? No? Alrighty, then we go forward. Alrighty, so again, today is the so-called Hello World Neural Network lesson or class. Have you ever seen something like this, or like something like this before? Like, is that something you have seen in the context of neural networks? Like, you know, you have like input, then you have this kind of weird structured lines, so-called neurons. Between the neurons you have the lines, and then you have these neurons stacked on top of each other, which we call layer, and then on the right side you have an output, and that's kind of how a lot of, let's say, researchers or people, when they talk about neural network and when they have to picture it, sometimes it looks like this kind of network structures. And today we're going to try to understand like what are neurons, what are these layers, and how does the information flows through this network and to make certain decisions. But let's start from the bottom up again. Remember, we wanted to hack, or we wanted to attack a certain system. Here in our example, it would be like a door that just opens when cats are in front of it and dogs not, right? It's like a, let's say, kind of a commercial product. It works with vision detecting systems, and it detects if there is which animal stands in front of it, and by doing so it can open the door or not. And we would like to maybe kind of trick the system so that every animal is allowed to get in there. Also coming back to last time, we talked about briefly this kind of, let's say, core parts of a network or core parts of neural network. First of all, we talked about data, right? I showed you a couple of data sets. MNIST, I think, if you remember, like digit, handwritten digits, or fashion MNIST, and what else? I can't remember what we had. I think we also had like animals probably and some other objects. And today we will more talk about the models, like what is a model, what is a neural network model, how do they look like, how can they be designed. And maybe also we have the chance to get a glimpse of what this kind of black box mean, because sometimes people say like neural networks are some kind of black boxes. So that's also another task. But let's start with this one. So the classifier between dogs and cats. And before we go with images, I would like to start with a simple example which makes it maybe more easier to understand how neural networks work. And first of all, we look at the data. So let's imagine we don't have a camera to identify dogs and cats. Let's just imagine we have two parameters. We have the height of an animal and we have the weight of an animal. So basically we have literally these two aspects of the animal. So when we have that, we can easily print them into this kind of graph. So we see, right, the C stands for cat and the X stands for dog. And when we plot them into this graph, we can see, right, that it looks like that dogs, first of all, are much heavier than cats and also taller than cats. So that's what you can see there in the graph. Is that somehow understandable for you? Like you see that, right? So on the right side, we have more X's. Those are the dogs. They are taller and heavier. And on the left side, we have cats. And they are probably, let's say, I don't know, 80-70% smaller and lighter. This graph, so far so good. A bit of math, all right. And we will see the problematic with this, right? Because we know that not all dogs are tall and heavy, right? And I'm not sure about cats, but maybe there are also taller or heavier cats than dogs. But still, let's imagine this would be our truth or source for the data set. Like here you see again, right? The frames, the left ones are our cats, and the right ones are our dogs. Let's imagine this as our data set. So basically we have to kind of define an algorithm now that takes the two inputs, the height and the weight, and then there must be some kind of algorithm or like model, and then the output would be, okay, when you give me this height and this weight of this animal, then I can make a decision if it's like a dog or a cat. That's let's say the simple task for first of all. So in the end, what it means, the model, what it needs to do is it needs to find some kind of line that which can draw between the two different categories, dogs and cats. So basically what the model needs to find is exactly this stroked line there. And maybe how long, depending on like how long the school is over for you, or like math class you followed, basically this line there can be described as this formula over there. Maybe as a quick reminder or refresher, so basically y is would be like that's what we are looking for. It would be like dog or cat. So that's probably a number. If it's positive, in our case, it would say like it's a dog. If it's negative, if y is negative, it would be saying like it's a cat. We just defined it. Now we could also reverse it, but for the moment we just say it like this. And then we have a. A is a parameter. We don't know it right now. It's something we have to figure out, so to say. And A is basically the angle of the line. A means like this is exactly at what angle the line will be drawn. Then we have X. X is basically the input, which means it's our height or our weight. And then we have plus B, and B is we call it also another parameter, but I can also already tell you it's the so-called bias. B is where the line is located on the x-axis, so you can push the line from the left to the right. And that's literally this is the algorithm. We just need to figure out the line to make a definition between the two animals. I know, quite abstract, so let's visualize it, or let's maybe write it down first of all in another sense. So basically what we want to do here is we would like to create an algorithm, again, that takes the height and the weight in it, that's our x, and then we would like to multiply this with a, which we don't know for the moment, but we just know we have to multiply it with it, and then we have to add b. So basically the simplest form of how to find the two categories. And again, if the output, so if y or the animal is positive, it's a dog. If it's negative, then it's a cat. To visualize this, basically it would look like this. And maybe now we come back to the graph in the beginning, where you see now suddenly these neurons or these circles, because basically every parameter is represented as a neuron in our graph there. So we can see, right, we have height and weight input. They are the two A's, they meet together at the B, or like at the center neuron, and then this one will spit us out the result, if it's positive or negative, or if it's a dog or an animal. But let's again, it's kind of, again, I would say abstract to mathematics, so let's have a closer look into this neuron, or into this parameter that we are looking for. So here's a closer look. The graph, what you see down below there, is exactly the mathematical operation on the top. And the question is like, what is A1 and what is A2? Because we know what is the height and what is the weight. Now we just have to pick a random number here. For example, I can take this one. So let's imagine this would be a dog, and we would like to, and of course the network doesn't know that this is a dog, and we just say like, look, I give you the height and the weight of this data set here, or of this data bit, which would be again our height and our width. And then I want that you multiply them with A1 and A2, and then add B on it. So A1 and A2 here in our examples are what we call the weights. I'm not sure if you have heard about it. It's like a very common term in neural networks. A lot of people, they talk about the so-called weights. That's basically these are the parameters the network was trained on. And this is actually the source, like this is where a lot of companies make, let's say, money with. And this is which they will never show you when you have like a model like ChatGPT, for example, or whatever. They are sitting on a model with the weights, which they trained for months and spend a lot of energy. And this is like the secret of our model, which they of course will not share with you because they have invested a lot of it. So here we have one thing, and then we have B, and that's the bias, and that's another secret of the model which nobody will tell you. And this is what we call, so to say, the black box, because most of the time we just get like a file, and we see all these numbers. We see, let's say, a list of a lot of, let's say, floating numbers around there, and they are represented for the weights and the biases, but we never know what exactly they stand for, what exactly they are representing. We just know, okay, they must be some part of the network, but we have no idea where exactly they sit in the network and how they influence the network. But maybe the main takeaway here for this graph is like what you see there, A1, A2, and B, or A and B. A is the weight and B is the bias. But so how can we figure out this A1 and AB, because we don't know them, right? We know we have X, we know that we would like to figure out Y, but how do they look like? So turns out that when you start to train a neural network, most of the time we start just with random numbers for A and for B. We just say like, okay, you know what, A1 is, in our example here, 0.4, and A2 is 1.1, and B is 13, and we just set it like this, and then we give them a try if it works out or not. So we give them a try means we put the height and the weight of a certain animal in it, we run it through it, and then we will figure out if the output is detecting a dog or not. And if it's correct, then we're good. If it's not correct, basically we have to go back and change these parameters. But let's do this together. So here, this is the first example. On the left we have our data set. On the right top is again our mathematical description as a graph. And here we're gonna set just some random rates again, right? So we have 0.4 for A1, 1.1 for A2, and we take 13 for the bias, random numbers. And then we put everything together. So here I decided I would like to give the model this exactly data point there. I write down the formula again, and then now I just replace the parameters with all the stuff I know. So we can see, right, we have A1, I take it from here, times 39, which would be the height. So here I can see that somehow on the x-axis, 39 plus 1.1 times 21, and then we just add the bias of 13, these random numbers, and let's see what we get. So when I calculate everything together, it spits out, it's a positive number, and as we said, like if it's like a positive number, positive means it's a dog. So here in this example, the algorithm works, and basically our random picked parameters over here work fine. But the thing is, do we know that it will also work with a data point that stays for a cat? So let's try it out. So I do the same thing. Now I pick a parameter, like a data point here for a cat. I put everything together. I have this formula now. Same thing, right? We take 0.4 times 27.5, which is here the height, plus 1.1 times 7, which would be the weight, and then we add the bias on it. And then, unfortunately, the output is also positive, so that means it detected this animal or this data point as a dog. So it seems to be that our random picked values here are not correct. So we have to basically go back and change them and have to figure out what will these three parameters be to correctly identify animal 1 here in our example as a dog and animal 2 in our example as a cat. So I would say right now with these parameters here, we probably define a line that looks like this. And we could not kind of really figure out 100% like how to split the two categories. And now that's basically the part where we start training, and this is or what we call training. So we have to basically figure out where these lines go through by changing the parameters, by changing the weights and the biases. And maybe here that's another example. So the learning means now we go back and do all the steps over and over again until we find the exact parameters to split the two categories. And the training is a bit like a mathematical operation, the process to find the right parameters. And of course, right, you can now do that by hand and like, okay, when I change this parameter, how will then the output? When I change this parameter, how will then the output? And by slowly, bit by bit, I'm getting closer to get the correct line or the correct splitter, so to say, between the two categories. And that takes time, and that's the reason why we have these crazy data centers. That's all what they do, basically. They always change the weights and the biases to figure out what is the exact separator between, in here in our example would be like between dogs and cats with regards to their height and weight. That's basically, it's as simple as it is. And it takes time and it takes energy. It's kind of surprising, right? But anyway, we have a quite easy example here, right? So that's obviously like this is something that takes a minute for a simple machine. And of course we are right now here have just two categories and then large language models or whatever. Obviously they have much bigger data sets, but still basically what they always try to figure out are just these values. Questions? Let's figure out the right parameters. Actually, I did that already for you, so I can tell you that these are the correct parameters you see, right? Like where I started from. You remember, like for example, for the bias, I had in the first example 13, and I did the training on a small machine, and I figured out that the bias must be minus 54, and A1 and A2 must be that. So here we're gonna do the same thing as before. We fill out the parameters here. We get for the dog, again, X is the dog, right? We get a positive output, so that's good, but we don't know. Let's hope that also works for the cat. And now I lost my signal. Here we go. So we're gonna do the same here. And the output is negative, and negative means it's a cat. So basically, we found exactly the separator between the two groups of animals. Oh, kind of losing a signal here. And that's basically it, what neural networks do. And as I mentioned before, the problem is not all dogs are heavy and tall, so we have an issue, right? And so what we just did here is a very simple linear separation on the left side. And most of the time we have much more complex data, like you can see, for example, here on the right side. And basically modern neural networks, they're gonna try to figure out exactly this kind of curved line so that you really get a very good separator between, here in our example, the two categories, dogs and cats. And of course you can imagine, right, this formula or this mathematical expression then will get much more complex, and therefore also it takes more or bigger networks, so to say, to calculate this. But in the end, the core of this network stays the same. You always have just this one neuron that has this mathematical expression. And what we can do now is basically just add more complex or more neurons into the network. And then we can do the trick to find out this kind of curved lines. And here you have basically, you see just as like two-dimensional, like when you talk about neural networks, this is like a very simplified way to understand. When we talk about neural networks, we have to think multidimensional. Basically, we're going to try to find these lines here in a more than 3D space way, so to say. But I think it's a good understanding of what these algorithms do and how they try to separate certain data sets. And again, from the beginning on, right, so we have artificial intelligence, we have machine learning. Machine learning is like an algorithm that enables AI implementation through data. So basically the first, or like the example we just did, is actually machine learning, because it's literally just one neuron. It's like one formula, so to say. But when you add more neurons and stack them on top of each other behind, then suddenly we talk about deep learning. So basically the definition here is like if we have more than 3 layers of neurons connected with each other. So again, we have, this is again the simplest version, machine learning. When you add more of them, and then in the end you have 3 of them, then we talk about deep learning. And it's basically most of the time what's out there, like how, let's say the network of Gemini, ChatGPT or Claude or whatever looks like. Obviously much bigger than this, but they have at least 3 layers, so they definitely have so-called deep learning network there. Also reminder here, right, maybe you see it better, here in our example, we have again also 2 inputs, then we have these neurons, and when they are stacked on top of each other, we call them layers. And here in this example, we have 3, well, yeah, I would say 3 layers, 4 layers probably with this 2. And then here at the output, they come together because they always, in this example, we just ask for a binary decision if it's like a dog or a cat. And so, questions. There must be a lot. What is the core of the network again? Like, what is the secret of the network again? What they will not tell you? What do you pay for? What makes it? Can somebody explain why it's so expensive, and what is the secret of a network to make it working? Okay, let's do it easier. What are the parameters of a network? We had 2. Somebody remember? A1, what is this? A1 and A2, how did we call them? Weights, exactly. Height, so unfortunately in our example we have a bit like a double meaning. So we have our data bit, right? So we have the height and the weight. So this is first of all our data bit. And then inside the network we have another term that's also called weights. So unfortunately here there is like we have a double word, so to say. So basically what it is this one, no? These are the weights, and then the other parameter would be the bias. These are these numbers which we picked here in the beginning randomly, and then over training and over time to figure out what they are. This is basically the secret of the network, and what's consuming so much energy and what takes so much time to figure out to get the correct output to identify, here in our example, dogs and cats. I mean, obviously there's also another secret, which is the network itself, like how these neurons are connected with each other. But most of the time these network structures are kind of known because it turned out that certain combinations of neurons works quite well for certain tasks. So the structures are actually not such a big secret, but again, the weights and the heights are the ones that they will not share with you. The thing is, in our example, again, remember, right, we have the door with the, and also we have this guy which doesn't fit in. We have the door with the visioning system, right? Like this weights and height example wouldn't work because we don't know the height and the weight of this animal standing in front of it. I mean, of course, we could maybe measure it and figure out the weight of it, and then we're gonna tell the system, look here, now I have the 2 parameters, please now decide what, open it or not. But of course we would like to be smarter in our example, so we would like just to take an image of the animal and then make a decision. So basically we have to find out here a different strategy to make a decision, right? And that leads us to more complex data, or let's say also a more complex model, because the other one was very easy. So that means we have to identify a different data set first of all, and we also have to reshape our model, the network structure. But let's talk about the data set first of all. Obviously we would like to work with images, no? So we have to work with a bunch of image data that we train a network on. And here the question is like, how can we transform images into numbers? Somebody has an idea, how can you transform, because we have to somehow come up with a similar structure as we had here, right? Like we had the height and the weight, and it gives us certain numbers. We could read it out of a graph or out of the table. And we have to somehow do a similar thing with images. So does somebody know how can you transform an image into a number? I mean, we know that they are based on pixels, first of all, right? Digital images. So pixels are in the end also just numbers, right? And what do we know about pixels? So let's say you have this image there. What do we know? For example, we know there's a resolution, first of all, right? So we know here we would have like 150 by 150 pixels. So that gives us, first of all, the overall amount of the pixels of an image. That's a good first starting point, I would say. But then we also have to transform the pixel itself into a number. And that's getting now tricky, because like how can I turn a color into a number? But as we are talking about digital images, right, we can easily split them, first of all, into our RGB. And we know, right, Photoshop, for example, like the color channels, like for example red from 0 to 225, I think, no? Defines like how red something is on the red channel. And you can do the same also for the other channels. So what we can do is basically we can kind of separate an image into the 3 base color channels. Then we know for each color channel the resolution, because it's 150 by 150 pixels. And then suddenly we have an array of a lot of numbers that represents this digital image as an array of numbers. So here this example maybe shows you, right, like for us, that's us, it just looks like a cat, but for the computer, and that's what the computer is always doing, right? I mean, obviously it doesn't know what a cat is, it just sees a bunch of numbers and then makes some sense out of it. So basically what we do is we're gonna, again, split the image into the 3 base colors, and then we have an array of these numbers, and then we can use them for our training. So that's like what a lot of, I don't know, you use in Photoshop every day, or like in Affiliate or somewhere. And of course also machine learning is using this as a strategy to make some certain calculations or decisions on it. Maybe here we can also, another representation would be, I take an image, I have the 3 layers, the base color layers, and each of them is 150 by 150 pixels. And once I have that, now I can work with them and run them through a network, or like feed a network with it, make decisions on it. But before it gets too theoretical, let's have a look at a data set, first of all. And therefore, I would like you to go to either this web page, nullisland.tel, but I wonder if it's been blocked here in the network. If this is not working, then you have to go to this one. Basically, it's the same link. So you go to Simon Weckert /machine unlearning /nullisland.html. Everybody there? Do you have it? Is it working? I mean, this would probably it's easier, but then I think you have to change to your private network or like to your mobile network quickly and just go in there, because I think this has been blocked by the university. So I'm gonna go there now. If it let me. Oh yeah. Okay, so this is the course webpage from the beginning, what we had last time as well. Here you will also find the other examples. Today we are in the blue section. And I would like that you go to the cats and dogs data set. So this one. And everybody there, did you arrive there? Works? Okay. So maybe as you remember, we had been to this web page in the last session. So this is basically a web page where a lot of researchers host data sets and public available. And what they do is then they say like, look, I have this data set, and now I'm gonna challenge you researchers or whoever or wherever you come from to create an algorithm that can do classification on these images. And here in this example would be like to do a classification between cats and dogs. And you can download this data set for free and then use it for a training of a neural network. And what we will do is now we want to download this data set and use it for our own purpose. So yeah, you can have a look here. Basically, it says like, okay, obviously we have images of cats and dogs. We can also see there are two different folders inside there. One is called training, one is called validation. We will have a look at it quickly. And then other stuff. But basically, let's download. I think here on the download button you can go. Probably you have to sign in. You can use a Google account, I would say, or you sign up here. And then here, if you go to download dataset, it's like 450 megabytes. This button. All right, also have to sign in. Okay. My testing. Let's see. Internet is quite slow here. go. So if I go to download dataset as zip, and that should do it. Wow, okay. That will take a while. I gonna probably, I mean I did that already, so I can show you how it looks like. Until we wait here for you. Let's see where we are. It's also so slow for you, right? Like it also takes time. No. Okay. Alrighty, so once you downloaded it, you will find again 2 folders in it. One is called train, one is called validation. Maybe you remember from the last session, but we always have 2 different types of data sets we want to use. Let me show you, I think I have it here somewhere. Yes. Maybe you remember this graph, right? Like where we talked about the bias. So we have this kind of pre-process of how to collect data, first of all, and the certain stages where bias could appear or could influence the data set. And then here we have the, okay, they call it data generation, or like, I would say, let's say the training and the validation of the model. And most of the time it's like this, that you train a model on a data set. That's the first part. And then when you train it in the same time, you always run it against a data set the network has never seen before. That's our validation data set. Here they call it evaluation. And that makes sense because we want to make sure that when we train a model, it's not being trained on this specific data, just for this in this specific folder. We actually would like to make sure that the model is good enough to also predict on data sets that has never seen before. And that's the reason why we use a subset or like a smaller data set, which we call validation or evaluation, to run it against it. And this is what the validation is made for. But let's have a look in the training first of all. So the training is this one. Then inside there we have 2 different folders. One is called cats and dogs. And here we can see inside that there are a lot of cat pictures. And I think when I scroll down, there should be around 1,000 cat pictures in our training data set. And you can go through it. And you see, right, they have different, different cats, different styles, and different backgrounds, different contexts as well, which is quite important for our model to make it stable, so that you literally just, you can show any kind of image of a cat and it will still predict it as a cat. So it will try to understand what does a cat looks like. The same is true also for the dog data set here. Also 1,000 images in the training folder. And yeah, so that's like a very normal standard data set. I wonder what's the resolution of it. Probably, it's like 512 by 512 pixel. So each of the image is already kind of cropped or like pre-processed for this resolution, which is quite nice. Still too big, but because we don't need such a big resolution for training our neural net model, but that's fine. And let's have a look here in the validation data set. Same story, but here we have, I think, how many? 500. So we have just half of the images compared to the training, which is definitely fine for validation. And it's the same story. But the more important part is that those images that you find here in the validation folder are not represented in the training folder. So the validation is a totally different, basically a separate training data set. And the same for docs here. And so yeah, this data is for free, right? We got it from the platform, so we can use it, I think, and it's good enough. I think also the training data set is big enough, so we can definitely use it and work with it. Well, then let's go on. Oh yeah, actually I have this one here again. So this is, again, as you can see, right, training, validation. And let's train our first model. Again, as I said, right, I'm gonna show you different, let's say, different angles of how to train this because it gets more abstract. The first example with the heights and the waves was more like, let's say, easier to understand. Now of the images, as I said, like we split them into these 3 different color channels, and then we have this resolution, thing like this. It gets more abstract to understand what's exactly going on. And what I would like to do is, first of all, I would like to do like an interactive demo, which is not coding at all. It's more like a very easy to use way to train a model with teachable machine. Then we do a live demo, and once we have that, we're gonna go into the code and understand what's going on. So now the next step would be, unfortunately, we have to download the data set. Is it done? Are you finished? Like, is it done? Amazing. So you can unzip it. All right. So basically, what I would like to do is, please go now to this link here, which is called Teachable Machine. This one, number 5. And I also go there. Alrighty, everybody here? Yeah? So Teachable Machine is an interesting platform. It's a very playful way to train models. So here we are right now in the image classifier. And what you can do here is you can basically train your own model in a very visual way. So here we can, for example, define classes. We can also add more classes. In our example, we just have 2, dogs and cats, so that makes sense. And here I can say, like, okay, imagine this would be my cat class, and this would be my dog class. And now this class here is asking for image data, or like for training data, right? So let's give them some training data. So here you can go to upload, and then I'm gonna go to this one. So I'm gonna upload data from my local folder, the top part. And let's see, we go in here, I go to train, and I go to cats. So the first class was cat. I select all of them, and then upload. Is that working all good for you? And we do the same now for dogs. So again, important part is we take the train folder, not the validation, because the train is much bigger. So more data, we get much precise or much better results then. Okay. Everybody here, like, do we have the data loaded? Yeah. So now we can train a model. So here, when I unfold this one, you see there are a couple of parameters. One is called epoch, the other one is batch size and learning rate. We just leave them as they are. That's fine. We come back into this when we have a look into the code, because they are the so-called hyperparameters. It's another term in machine learning, which I will explain in a second. But we just leave them as they are, and we train a model. And it takes a while. And also, in that time, you are not allowed to close the tab. Otherwise, it will not train. So this window needs to stay open. It also tells you here on the top, right? And now we see right here it goes through. I think there's also like a status somewhere. Okay, maybe that's the only thing we get. All right. And again, I think this one also now runs on a Google infrastructure or like somewhere on a different data center. So I would guess so, not in your browser. So we should also have the same time period here to train the models. Okay, almost done. Maybe, okay, we don't see the numbers anymore. We see, okay. Okay, now it's asking me to open my webcam, maybe for later. I might have this one, well, it's fine. But actually what I'm interested in, I'm not want to, I mean, it's kind of interesting, why not? So basically you see, right, that here on the bottom, it's now doing like a live detection of what it sees. I'm not sure which camera it's this one. So it seems to be much more like a cat. I wonder if when I show, okay, so for some reason, something was more like a dog suddenly, I don't know. But however, I mean, we are just interested into images first of all. So I can upload an image now. And now I can obviously also use one of them here, but again, we should say like, we would like to show now the network an image that's never seen before, so therefore, we need to go to the validation data set. And then I'm gonna go into docs, just select a random image, upload it, and we can see that this one got classified as a doc, so it seems to be the network is correct or it's working well. Let's do another one. Go into the cat folder, and this one got correctly identified as a cat. And right, I mean, this is a super simple network and it was quite quick to do so. If this is not working for you, I have also here the teachable machine demo, and you can also click on this one that will guide you to the already trained model, where you can do the same thing. Basically, it's the kind of pre-processed model that runs in the browser. You can actually also now do the same thing on your end. So I think once that's done, you can go to model export here, and then you click this one, upload model, and this will generate a link for you, which you then can share with anybody, or you can implement this into your web page, for example. If you ever want to, build some kind of image classifier into your web page, you can. Here it also describes you like how you implement everything then, and this kind of things into your web page. But yeah, if you click this one, it will generate a link for you, and then you can share it with others. I'm gonna reload because this web page also has some interesting functionalities, as you have seen, right? The webcam. I might gonna do it the same here. So for example, I can call this one smartphone. I'm gonna start the whole thing again. Smartphone, and this one is hand. And now here I can generate a data set in real time. So when I click on webcam, it asks me for the webcam access, and then I hold up the smartphone like that. And once I click it, now I can generate a data set in real time of the smartphone. Now I do the same for my hand. I generate a live data set of my hand. Maybe, let's say 200 images is fine. And then I click train. And then after this is done, basically it should identify if I hold up a smartphone or a hand. Very easy. Oh, it's pretty quick. All right, so let's see if it works. So this is the hand, it seems to be okay. And this is a smartphone. And you can see, right, I mean, I didn't pay so much attention to all the rotations of the smartphone. So already if I put it like this, at some point I can flip the categories. So like, I mean, obviously maybe it also makes sense, right? Now it's the hand and now it's the smartphone. And with this kind of stuff, you can already then go forward on, I don't know, like build some interactive installations or things like this just by flipping the categories here. And then, of course, you can also hold up other objects and ask the network what it sees more. And it's kind of interesting, just by rotating it, it already has an influence on the categories. And the interesting part here is also that Teachable Machine, when I go to the first page, I just click on New Project, you can do the same with audio as well. So you can also do, for example, an audio classifier. So this one would be like, I can say like, every time when you hear this sound, it's like a hello or whatever, right? So it's the same structure just for sound. And here we also have pose detection. So I assume like you can stay in front of the camera, and then it does like skeleton tracking, and so might be useful for some of you in some projects to play around with this one. Any questions, or did you is it good? Like, did you try, like the cat and the dog thing works, right? It's fine, yeah?
Yeah, I have a question. Somehow in the folder with cats, there's a puppy.
Oh yeah?
Yeah.
Okay.
I don't know if it's a mistake or...
No, it's not a mistake. We will come to this later, yeah.
Okay.
Yeah. But it's good that you're saying it, because exactly, right, you always have to look at the data set. I mean, we assume that inside cats there should be just cats or dogs, but you never know what's inside, right? So you never know. Just a matter of fact that the folder is called cat doesn't mean that there are always just cats inside, right? So, but it's, I will come to this later, and yeah, there are also other, I mean, if you like so, there are also other, let's say, bugs in the data set. Maybe you can identify them. But exactly, right, it's a known issue, let's say like this, that researchers, they upload data sets, or people upload data sets, and they say like, this is the best cats and dogs data set ever collected so far in the world. And if you can write an algorithm that can detect these two animals out of it, then basically you have the best algorithm. And it happened already that suddenly people figured out that these data sets got manipulated. And what then the researchers did, they wrote algorithms on neural networks that were trained on dogs, but in fact, basically, they trained it on cats, because in the data sets there was a, let's say, malicious data set in it. So never trust these kind of public, or always double check these public data sets. Okay. So I think this one is pretty. I mean, of course, well, we can also add another class here. Take this one, and then I'm gonna take this one quickly as well. it's maybe more stable, so the more rotation and angles and different sides we show it, the better it gets. Let's do it. It takes a bit longer, but it's fine. Alrighty, so now we see, no? The output has 3 different categories now. And this is interesting because like the smartphone and the bottle, they kind of look, you know, they have the same color, but still it's kind of okay-ish to identify this one. Aha, now we see also it starts to glitch a bit for the bottle category because I would say the color is kind of similar. It's hard to, and the hand is quite stable. So here we are kind of facing that I would say the smartphone data set is too small or not good enough. I mean, it still works, but it's not very stable. Alrighty. So yeah, this one I showed you, right? You can share it with people, you can implement it in your own webpage, do some photos of people in the background, for example, when they visit your webpage, face detection, for example. And the next part would be the model, but I think we might gonna do a quick break, and then next we will talk about what is behind this teachable machine, what's running there, how they make it, and that's, I would say, for the second part of the class. So let's do a quick break then for